Hello, and welcome back to the devlog. This is number 6, week 6 of development on the indie game. So I started off Monday facing the worst problem. Um, it was a harsh way to start a Monday. So basically, the problem was that my XR controller, as soon as I connected the right controller, it looked like there was some sort of interference. Looking at the reads, I was getting a values when I pressed the controller, but then it would quickly be send a cancel message with a 00. So it was getting called twice, and the result was that the movement was non-existent. It was like fighting against itself. There's something going wrong. So, and another thing, the frame rate was dipping to like 20 frames per second. That was no good. So two problems. It's like, how do I solve this? I spent a lot of time getting frustrated, but these are the times that separate the men from the boys in programming and software development. You either go home and quit or keep testing. So, one of the tricks of my bag is the process of elimination. You narrow down the issue. So, in order to narrow it down, I went back to my original um, top-down engine prototype and implemented and got the controller working again because it was broken from importing the Invector system. Um, this test told me that it was working when controlling the right controller. It told me that you're using the TDE system now and the controls are working, so it must be something wrong with the Invector system. Okay. Um, next. I went to the. I implemented a XR basic simple XR rig in the Invector demo scene to see what would happen, and noticed that with their character controller, the frame rate was fine. The frame rate was fine. It was at 20 frames per second. This gave me another clue. So it must be something wrong with my scene, maybe my character. Okay. So, and then the XR rig with a simple input, letting Invector handle the input from the XR controller, it was fine. When you connected the right joystick, everything was working. So it definitely solidified the fact that, you know, it's the Invector system, but also I'm doing something wrong with my input system, doing events, reading from events. So I went back to my scene and I removed the input for the joystick, the event input for the joystick, and let the default legacy read from the input, and that fixed the issue in my demo scene. And that's okay, because joystick input is and movement is agnostic. I just want to have an override for custom buttons like stealth to send out an event to listen to. That's fine. Okay, one problem down. That took some doing. That was a pain in the butt. Um, Next problem, looking at the cat model, messing around. I I was looking at the model and turning things on and off. I began to realize that turning off the one of the stealths actually bumped the frame rate up significantly. So the problem was it doesn't like having multiple skin mesh renderers at the same time on it's just a lot of CPU to calculate it. So I could cut down that cost by actually writing some logic in the script to actually hide these meshes, deactivate them when they're not in use, and only activate them both at the same time when I'm doing the stealth transition. Um, Testing that out, the performance issues went away, and we're back to being good. Um, Finally figured those out, feeling good. And that's the part when you figure out these tough problems and you win. It's like, yeah, that's what it's all about right there. That's why I do this. So after those were behind me, I began thinking about what to do next. So I wanted to move on to the enemy AI. Start get the AI working. I messed around with it previously with the TDE, but I found that it's very basic. It works. At the end of the day, I started wondering if there was a better AI asset on the asset store that I could use in favor of TDE because just like the character controller, it's very basic, and it only probably only bring me 50% of the way there what I wanted to do. and I'd have to spend a lot of time and work implementing the rest of it. So searching the asset store, I came across Invector AI add-on again and purchased that, thinking it'd be a good fit because I'm basing my main character logic off the Invector system. So that brings us to Tuesday. Turns out I was right to purchase the Invector system. Diving into the documentation and the demos, it offered a much more wide feature set that would probably bring me like 95% of the way there, or what I wanted to do, much better. And it integrates nicely with the Invector system. Offers a lot of great tools like the um, the state manager, visual state manager, and the debugger. But the trick was to actually figure out how all this works, and that's what the court did over the course of this week. So on Tuesday, just setting up just messing around with their demo scenes, and my first challenge was to try to get their demo controller mesh swapped out with my own mesh because I wanted to use this robot mesh and animations for the controller. Um, took some doing, and I finally got it figured out. Took some finessing because the problem was that the AI system is set up for and assumes and is tested for a humanoid rig. Now it's not impossible to use a generic rig in animations, but it took some understanding and work to actually make it happen. So I had to use their default controller and kind of swap out a few things, but eventually I got it working to somewhat satisfaction. The next task was figuring out their waypoint system, hooking it up. How do you get controller to move, the AI controller to move to a certain point? So looking at their waypoint system is kind of similar to the top-down engine MMPath they use. You put down these paths, except that it's a little bit more robust in that it uses a nav mesh to navigate itself from point to point, and that it can actually go off the path and find its way back. So figuring that out, hooking it up, I was able to get the robot to do its path navigation again in a patrol from one point in a cycle. That's great. So I'm back to the same square, moving totally off of TDE. I think TDE still has a lot of great features as far as game management and level management systems that I would use. So it's not totally out the door, but it just doesn't have advanced controller features that I'm looking for. Okay, one of the problems I was running into with the navigation is that he's so big. He's not just a humanoid. He starts when you put the waypoint over here, like over here. He goes to it, but he gets caught on the edge of the obstacle. Because the nav mesh is so close, it calculates from the center of the nav mesh, and his legs get stuck. It doesn't. So even if you put a radius around him, the system doesn't say, oh, calculate the path from the edge of the radius. That's not how it works. It'll calculate the center of the center point model, and everything outside of it, it'll cross over the nav mesh line and get caught on there. So that was a problem. Like, how do I solve that? But I put that on the back burner for now because I wanted to start to look into enemy detection, and now we're crossing over into a new realm. TDE had some enemy detection built in, but now we're talking about building our own custom enemy detection states and whatnot. So that brings us to Wednesday. So figuring out how to hook up the range visual debug system, and basically I had to upgrade the basic AI controller to an AI combat controller in order to enable this debug visual in the editor. and then looking into what all this means, what do these circles mean, the detection, messing around with the settings, and figuring out, diving into the code and like how does the detection system work, looking into the FSM, the finite state machine graph, this here, and kind of using the demo and doing a lot of testing, having them patrol and then having the character here, the layer, having him spot, what happens, how does it transition, looking at the changes in code and understanding the system, how it works, using their demo setup. Trying to figure out how to make my own state machine from my own custom behavior. So a lot of learning and understanding in that respect. So getting a lot of knowledge and information, but I was still facing the problem during my testing that he was always getting caught on this thing. So I turned my attention back to that problem. How do I get him to not get caught on this? Because that's going to be important. So testing a bunch of solutions. I tried to extend the obstacle. What is it? I tried to extend the nav mesh obstacle radius, but baking again would actually these cover points have to be on the nav mesh in order for the character cover system to work. So that wasn't a solution. It would extend it out here and stop him getting caught, but it would break the cover system. So, what was the solution? So eventually I came across things like in my research, things like nav mesh areas. What does that mean? Defining a new area. And then agent area masking. So when you're on the nav mesh agent, wherever it is, here, you can mask off the areas you don't want to go. So all these you can go, but this you can't go on. And then most importantly, the nav mesh modifier volume. So sticking this on the prefab and defining it a little bit extra space and then rebaking to an area type robot, it gives us another color here. And now that's the solution. That's that's something I envisioned that I wanted to do, but I couldn't figure out what it was, and then I'll finally put the pieces together, and that was the solution. So now his center line goes through here, and it's enough room for his legs to get to the waypoint. Okay. Problem solved, exactly what I wanted. Moving on to the next issue. So I did a cleanup. Every once in a while I do a cleanup, go back, toss out a bunch of prototype files that I used, prototype scenes, reorganize my file structure to make more sense as you go. You can't have a complete mess. One of the things I decided was to only subclass and use wrapper classes if I'm going to modify the behavior of the underlying framework, like in Vector. It doesn't make sense to just modify, to add a wrapper just to add a wrapper unless you're going to add some overriding behavior on top of that. So a little bit of cleanup, and I turned back to my custom enemy state machine, learning about things like, how does this work? Actions, decisions, adding new states. Each state has an action, and actions define what you're doing during the state. For the patrol state, you're patrolling, you're moving around, and in the patrol state, you're finding the target. So you're scanning on the update, you're looking to see if a target has entered your field of range. And then you have your transitions, and that's where the decisions come in. How do you transition from one state to another? Patrol doesn't transition, but from any state, he has two choices here. He looks at his decisions, and he can go to the chase state. You can switch over here. You can go to the chase state if all these conditions are met. So when he's walking, if he can see, as soon as he enters the other, he can see, he will, that's true, but he's not in combat range, he'll go to the chase state. And that usually means, and you can define certain behaviors, again, with actions. In the chase state, you can say, oh, his speed, I want him to move faster like a running, and that'll, so you can define actions in the state. So the transition to other, and then the combat range, or from any state, you can go to the combat range. If he can see and he's in the combat range, which is this blue, then he'll go directly to the combat state. And then for a full cycle, coming back, he's not in combat range anymore. This could be a little better, but yeah, he's not in combat range. He'll go back to chase, and then in chase, you go back to the control if he can't, go back right to the patrol if he can't see the target. So very basic. There's definitely a lot of finesse and work that can be done here, but that's for the future. But it's a full cycle, and it's a framework of something basic. I had to clean out a lot of the extra stuff from the demo controller, but this is a good starting point. So I spent a lot of time diving in and exploring all this code and systems, how it works underneath the hood, and making new actions. One of the issues I ran into, I wanted to keep my project clean and add these new custom actions into my own game folder. But the problem is Unity was giving me an error. The FSM system didn't like it. It couldn't locate the new actions and put them in this menu here. It was crashing, and no matter how hard I tried, it gave me some sort of weird error. So I had to make a compromise and put the new actions inside the package folder. Now I don't like that, but it's better than sitting here and trying to debug some obscure Unity error that going on the forums, there's not much help. It's just okay, whatever it is, what it is. I can spend hours or just put it in here, make an exception, move on. That's how it goes. So keep on working on it, just running into normal issues, no brick walls, no huge roadblocks, no huge problems, just kind of plodding along, getting things done. Bringing us to Friday. In my testing, I was noticing that one of the features that I think should happen, if the spider enters the range and he sees him, his turret should turn to face him. And that's what I started exploring the head tracking system that Invector offers. Now that's a whole other system in itself. And what the problem was, it's using their built-in look action. In their demo scene, it worked. It turns the head for like a humanoid character, but in this, it was built in the context of their demo scene, their character model, and putting it in the context of my robot model, it turned out to be completely faulty. It was no good at all. The turret would spin wildly around. I'm not sure what happened. This is the time that I have to make my wrapper classes, my subclass, to go in there and modify behavior. And I was really getting in the weeds. I'd worked with rotations and stuff before, but never really understood. It's kind of following along, and now their implementation was no help to work as a model. Like, I spent a lot of time testing, but not just not really knowing how the whole thing works. It's kind of like you could spend a lot of time, or you could sit down and actually learn how quaternion rotation, how this works, and that's eventually how I solved it. I took a step back because I was just wasting my time, testing this, no, that didn't work, testing that, no, that didn't work. It's very inefficient. So until I actually sat down with a video and be like, okay, I got it working with a basic quaternion lerp, but the problem was that if you go around the enemy, at some point, the 360-degree point, he would actually turn all the way around again. So that was no good. So he spots you, and I wanted him to be able to track you all the way around. But as soon as he hit a certain point, the Quaternion Lerp was not a complete solution, because he would flip all the way back around 360 to spot you, and that's no good. I want to be able to track you smoothly all the way through. So until I sat down with a YouTube video and looked at a different solution and how to get, you know, infinite 360 rotation, you know, you just got to do things the right way. You can't just mess around. But anyways, so got that done at the very end. That looks good. And now we have this basic thing where now he'll follow you around if he's in a certain range. If he gets in combat range, my next step is to, if he's in this range, he'll start shooting at you, which is the fun part, okay? Another thing, you know, if I go invisible, that's a non-detection. He will lose track of me, and he'll go back to his patrolling. So we're in the start of something good, and the cover system works like a charm. He doesn't spot you if you're in cover. So yeah, we're looking pretty good for a week's worth of work. I'll continue on. If you like this content, go ahead and like and subscribe. I'd appreciate it. And we'll catch up with you next week. Thanks a lot. See you later.